Example 1, exercise chapter 9. We are gonna make a PCB of an op-amp and having 6 layers. Please open a new file. Select the PC block wizard. Name it as an analog example 1. It's an analog signal with a dual power DC supply. In the project wizard, add the files, like we need files for the connector. These are the already prepared file capture files. These are the files which we need to make an environment, because we're gonna use the components, so we have already made files for them. You can download from the website, or you can get in your folder as we have scrolled it down. Select LM7411 op-amp. Place on a schematic first. Select a 6-pin connector. In the connector library, you have 6 pin, all pins in same row. Circuit is very simple. It connects only a point to the active components, and passive components are like resistors and capacitors. This is the through hole component connector, power supply, filter, capacitor. This will just have a 15 volt positive, 15 volt negative DC supply to the op-amp, and we can give any input and output. C1 C2 capacitor. During the entire process, we will continually add information to the spreadsheet, to the document, and organize all the aspect of design. Here the J1 is the connector, 6-pin through hole. It's like 0.22. C1 C2 is 10 picofarad capacitance. C3 C4 is 0.1 microfarad SMD size 20. The down one is the SMD surface mounts, and the U1 is the LM74 SOIC, also surface mount. This all 3 resistors, 4 resistors are 1K, 2K. They all will be SMD surface mounted 805. At the feedback resistor R3. The input pin number is number 5. Upper 3 pin is connected to the connect the circuit as shown. Here pin number 1, 2, 3 is the positive negative dual supply 12 volt DC, and pin number 3 connected the ground to all the components, capacitors, op amps. Pin number 5 is the input, 6 will be grounded, and pin number this is ground for the J1 J2 or C1 C2 capacitance. So between 5 to 6 we are giving input, and between the 4 to 5 we are taking the output. So pin number 5 is the input and pin number 4 is the output. So take care of this confusion. So this is like in the connector 6 pin we give the inputs and outputs, and inside on the PCB there is a power supply for the op amp. On the 1, 2, 3 pin number we gave positive and negative 12 volt dual supply, and voltage between the op amp is like normally 15 to minus 15 negative supply, positive negative like 15, so it works on that dual voltage. Make sure that all the components are connected well. Please like zoom in, and the op amp get have like 2 pins were input and output. It is giving input at 3 positive terminals, so whatever input will be positive, not inverted. And pin number 7 and 4 is the positive negative voltage supply, which is normally 15 volt plus 15 volt minus, or 12 volt plus 12 volt minus 5, and number 1 is the output pin. That's gonna be the arrangement. The op-amp we are using in this example has a visible power supply pin, so we can use their global properties. Now select particular component and select value only. Calculate the bill of material. Header file will be the footprint. This will create the bill of material in the Excel. Type PCB footprint. Click on the open in the Excel. Browse the report where you want to generate. This will generate the bill of material, that what material components we are using and list of the components in the Excel sheet. So this is the item quantity we want, capacitance, and now we want footprints. Footprint is the components, like dimensions what we're gonna use for our project, like structure what we use it. So we have to notify that, like surface mount, crystal, capacitance, whatever it is. First of all, select the capacitor C1 and C2. These two are the axial capacitance, so I'm gonna use it. Radial, so it will have a 2 pins from coming from the cylindrical head. So select both of them, scroll down. In the PCB footprint, print edit. This is the already made files for the components. For the footprint you can download from the internet. This is like C capacitance in the picofarad range, like 17-10 picofarad. This will connect to the component C1 and C2 to the what dimension they are, what value they are, what type they are, what material. Already files you have to download from the internet, or you will have in your particular folder as shown. Right, in the PCB footprint, click that. Same for this two ground capacitance C3, C4, they are SMD, surface mount capacitance. So SMD resistance. So this means a particular resistors or capacitor, what they are, what type of they are, what dimension they are. This will have footprint. So how they will be mounted on a PCB. They have all that file. We are gonna link that file to the PCB footprint or particular object. So these are the three surface mount resistance, like R1, R2, and R3. Now for the connector is like 0.200 gap, and it's also for the connector. The file is connector 6xx. These are the DRA file you will find in PCB underscore library. So make sure you find it. Edit connector 6. Now this is the open. This is SOIC open. So edit the part. Go in the same dialog box. SOIC 8. This is 8 pin op-amp 741. So select SOIC, up, surface mount IC op-amp. Copy that file. Make sure you have this folder in the backup, otherwise adding them in the schematic properties of component doesn't make any sense. Go in the PCB footprints. SOIC 8. Apply. Yep. Make sure you have all footprints. Yep, we have all footprints in a bill of material. This is needed because when you go to the vendor for the component, he asks the footprints, how you want axial, radial, ceramic, surface mount, whatever. If you have these things, you can search the component in the market of suppliers. Now we will be grouping the related components in the one rooms. So we make all the C capacitance in one room, make all the amplifiers or resistors in a one room. Now this is done by just selecting the components, like as we're gonna make room, edit the part, so we get all the three resistor in one row, and go in the option button, room. So make the room as a resistance. So this will be the edit. All the grouping of the rooms will be done. All the resistors. This is very important because in the complex PCB, this is small PCB, but in the complex PCB you want to make all the components in one room. So because it just helps you in an analysis, if you want to change one component, other component, want to see what's going on, order the things, that helps a lot. Also in making this silk screens, whatever you want to do on PCB, if you have room, it helps you. It's a room for the op-amp as an amplifier, whatever you can name it. name it as an amplifier stuff work. So all the amplifier stuff kind of PCB will be grouped on with the amp dot stuff, because when you get a designing which get complex ahead, so it's better in the beginning you make all those rooms and all those things, because that helps you a lot before it becomes too much complex. These are all the bypass capacitors. So we're gonna include in the header at the slash room file, and in the property string, combined property string, we're gonna make slash t ROM. So the rooms will be included in our bill of material, because we also need the grouping in our bill of materials, the document which is gonna print and go to the vendors. This is very important when you have a complex when you're supplying something, you need all those things as a documentation when you're gonna give to your client or something. So if you have a footprints, rooms, reference, quantity, everything you need to specify, and you need to all have it on the Excel sheet. That's very important as we go further in the commercial world. Annotation is a simple procedure which annotate all the pins in the circular way or in whatever incremental way. So this will you annotate as per the PM page ordering. So this will like annotations of all the pins in the regular form, like pin of op amp, capacitor. We will do annotation in incremental order. Now we are gonna have clean up the cache, because the cleaning up as you remove the unused part on the design. There are some things left over, some connectors, some grounds left over. So this clean up the cache. Now this is the schematic ready. Now we're gonna do the design check rules, because there are some issues which you don't know, but DRC checks all the nodes, all the net, all the pins conflicts, duplicate names, and the rules, missing pin numbers. So this is a matrix, particularly interesting part. From this matrix you can analyze that what particular output, what particular thing correspondence to that is either having a warning on that or notation on that. So this helps you a lot. The DRC is important because many things we even don't know, which is conflicting and which is not creating the design as we want to make it. We're gonna create the net list, which is important. Select the PCB footprint, create in the Allegro, the create and update PCB editor board, and open in the orcad like PCB editor. So this will update the our schematic connected to the orcad PCB. So this was all the component on a page. Now it will connect all this file and bring to the PCB format. So open the PCB designer. So we have components, freak footprints. We're gonna combine all those stuffs and we're gonna enter on the go in the setup. So in the setup, go in the design parameter. First thing is that we have in the our design profile which gonna generate, we gonna have what the units we are using. Sometimes we use in centimeter, sometimes millimeter. Make sure the units are okay. Width is 34000 and size is D size, all values in minutes. So this will gonna generate the grids, the dots. Now we can specify what's the distance between the two grids. So grid on non-each layer will have the 100. So distance between x and y will be 100. No offset is given. It will be same as for the each, all each, non-each. Each is the where the copper is removed. Non-each where the no copper is removed, and silk screen is the white pattern we're gonna form. So top and bottom, each and non-each. All the each will be the where the copper is gonna removed. So this is important because all designing will be on this grid. Measure the distance between one. You will see in the deep. This is the tough part. Click on the etching layer will be the top, ground, power and bottom. This will be the copper tracks, and all each will be the top and bottom, ground and power. Non each will be the where the no copper is removed. So we have to make outlines. First of all, we have to make an outline board. On a PC we have to outline of 200 millimeter, 200 board clearance. So this will be the portion away from the plastic like board. Draw polygon. This is tough part. Click the draw polygon board in the board outline dialog box. Then the left click and release once in the work area. So the left click, release once in the your work area at the right vertex of the board. So at the right vertex of the board, release your left click and make the board outline about like 5 cross 3, like 5 inch in the x-axis and 3 inch in the y-axis. Go 3 inch in the y-axis and go 5 inch in the x-axis. Don't do, and this is tough, but make sure you're doing well. Yep. Now keep looking in the down. Yeah, this is the border. This should be like 5 cross 3. If you want to make a line, you have to stop click. Apply. Spacing is like 10. So this much is the part away from the exterior of the board, which will be the part of a PCB. So this is the portion, the finished board line and keep-in the area. So inside one is the keep-in area, the purple one is the keep-in area, and the outer white one is the board outline. make sure all the dimension is okay. There should be like 4 or 5 dots margin. This is like a margin. Now we're gonna make a holes where we're gonna like on the schematic of the PCB you should notify that how much grid equals to 1 inch. So this is which one we're gonna do as I'm doing. So this specify that this much grid equals to 1 inch. Our PCB is of 5 inch cross 3 inch. Go in the linear dim. So this much grid equals to 1 inch on our profile. Now go in the manual buddy. In the manual button make mechanical symbols. We're gonna make a holes, 4 holes for the screws. Go in the database library, select for the MTG125. See in the graphics quick way, place this MTG125s on the 4 corners. These are the mounting holes for our PCB. Scroll up. There are different terminology for the holes. So like mechanical for drills for the CNC machine. So we are using the MTG125 at the 4 corners. So these are the 4 folds. We have it. These 4 folds are in the corner. Now we're gonna have how the 4 holes will be. These are the non-plated holes. They need to be non-plated. These are the pad stick. One we got. We're gonna have drill it like circle. It should be non-plated, and drilling diameter should be 125. these are all the parameters for the go in the non-edge portion. Non-edge is the all the way the copper is gonna not remove, the copper tracks will be found. Make it at all 50. Go in the quick place. This is like we gonna placing the part. There are three basic way, like we gonna do manually, also we gonna make by quick place method. This is the quick place method, in which we gonna go in the room outline. We already defined the room, so we gonna first have one room for like amplifier stuff. So this will bring all the amplifier stuff over here. It will draw rectangle amplifier stuff. Now scroll down, bring all the resistors. Oh sorry, bypass cap. We gonna do right now bypass capacitor. So we have 4 bypass cap. Place all the capacitors. Quick place all the component, place by the room. On all the rooms, go again in the amplifier stuff. These are the bypass capacitance. Now use the move to move all those components. These are the SMD capacitance. To bring all the SMD components in the bypass capacitance. Go in the J1 connector. The placement, this will bring but J1 should be placed at near the outer edge of the PCB. Keep it over there. Select the C1, the axial component, axial resistance, capacitance, sorry, the radial axial, C2, 2 capacitance, and op-amp U1. So these are the placement of the component. So we have placed the 2 capacitance, 1 op-amp, 2 SMDs, bypass capacitance SMDs, and 3 SMD resistance. Now checked out. Now make sure that the connector is in the slot which if we form the outer rectangle. Bring that in the outer rectangle because we're gonna connect it to the outer world, but in the inside it should be on the board layer. It should be equidistant from all the grid. Now move the capacitance a little bit further, spin it, because one of the capacitance polarity is inverse. We need to rotate capacitance C1, spin it up. So these are the DRC error we are going to be. This will come because if the component is not in the distance, component has not too much crossing the layer, overlapping somewhere. So make sure that by check the DRC error. See the C1 has to positive up. Move this, make sure DRC is now coming. Please don't make no noise and recording. Just move the capacitance away from rotate the C2. So this one has the C1, C2 color. Both negative are connected to the ground and the positive is connected to the outer world. And this is the op amp. See, 3 number pin is positive. We're gonna change it. We're gonna make insert the pin number 8 because we are using the SOIC 8 surface mount IC is a 8th component. So 8 will be number as NC. It make it as a short passive. So this will be like, this is the no connect pin to the capture. This is no connect pin. You need to update that change which we have done in the op amp, because that's gonna be on the PCB. Go in the Allegro folder, go in the analog, go in the open board in the PCB auditor. I'm sorry, do not open the board. We need to go in the input file specifier. So we're gonna updating the board. Go in the capture. So this is the all connections already have done. Make sure it is a CIS capture. And make sure the path, it must be the slash. This will import the cadence logic, import the ECO information with the logic. This is the U1 component or op-amp. This is the SMD 2K surface mount resistance. We are getting the DRC error on this one. The red, this one means the DRC error. So make sure you make the R1 out from the room of the op-amp, otherwise they will generate the errors. Remove R32. Update the status. So this means that the unplaced symbols 0%. It is like almost ready. This shows that go in the quick report. This final DRC check, this will generate as a report which gonna be printed out. So there is no DRC error, but if you have DRC error, you can print it out and see what kind of error and proceed further. Like, this is very important when you are in the company. There are many departments like mechanical department which do the drillings and all those stuff. This is the layout cross section. The first top layer is the conductor. Make all the layer. FR6 is a dielectric material. Over here we do not need the dielectric material because we have all the copper in the surface layer. In our layout we have the top layer, bottom layer. This is our project is of 6 layers, so we're gonna have the our project have like first top and bottom. In between there is 2 ground, and in the middle there is a 2 positive and positive way and negative. So what we're gonna do that we're gonna make conductors. Do as I'm doing. The plane to all is the conductor is a copper. The plane means the red ones are the conducting coppers, and the top and bottom is positive. The V positive, V negative, ground T, ground B is all negative. These are all power and ground. So make sure the plain ones are all the copper. Their material is copper. Type is plain. So ground T, ground B, V positive and V negative. These are all negatives. So check on the negative artwork. Check, unclick the shield. We don't need the shield. Thickness should be 47.2. FR4 is the dielectric fire resistant. We don't need that. So this is like defining the layer and visibility. We can define the color over here. What kind of color you want for the top layer, bottom layer, V negative, V positive, ground, whatever you want to select it. So V positive all pink. We're gonna make the light colors to this. So V positive is pink, V negative is sky blue, ground T is all pale yellow, ground B we're gonna make it as a pale yellow again, bottom one we giving the red. So in between red and green there is all other layers, ground T and ground B. So ground is of color of yellow, and V positive and V negative, V positive they have pink and blue color. So make sure the solder top and solder bottom, these are all the layer which we need because we want to place the SMD on that. So we need a mask where we want to put the solder. So there are two sides of PCB, top and bottom. So these are the particular region where SMD gonna fix it. So they already paste solder on the surface of PCB, and we just put the SMD component and just give a hit. So this is for the SMD component, solder mask and solder bottom. So these are the all visibility we gain. Top is red, green, bottom is red, grounds are of pale. This if you select each, if you select where is gonna be the grounds, so this gonna show by the layers, the visibility of the layer, visibility of shown by the color, the plane outline, so how the plane will be. So draw the polygon, that will be the ground underscore signal. So this will be the outline of the plane. That's the region. So color this one at the region where we're gonna form a layer. So this one is the ground signal. This is a pouring a copper plane using the shape add tool. This is a V positive, pink color, make a polygon. These are what we are gonna doing this. We are adding the planes, showing them they're gonna be your regions. each V positive, dummy net go in the V positive. This is the net gonna be formed. Outline of the plane outlines. V negative. Browse it. Netted V negative. Draw a polygon. No, we are gonna copy from the plane, sorry. With ground T. So the same with the ground T region. So we are defining the region of that. We need to make for our 6 planes. So we right now go in the negative, ground B, dummy net each ground B, options, yep, ground T, yep, it's over there. Make sure it's all over the plane. Option, top layer, yep, top layer, V positive, bottom layer, yes, top and bottom is all needed for the connectors. This is all the copper where tracks are formed. We're gonna verify the thermal pads because we are using the assembly components, and there are times which we do not want too much heat to solder because it may cause the troubles. So we give thermal pad, we get certain patterns to the copper surrounding the pad and the mask of solder, which helps to dissipate the heat in such a way that we only get the heat at the where we need it, not too much, which can cause a problem to the board and the component connections. So pin number 4 and 6 will be connected to ground. So first is the ground plane, the top, ground and bottom. So the pin number, the holes, these are the holes where V negative is gonna be there. Uncheck the V negative, check the V ground. V positive layer should be to pin number 1, else leave connection open. Pin number 4 and 6 is the ground connected. Select the dimension of the thermal relief. There are all the pads, circular shape, flashy. These are particular designs. We gonna use TR180 150. This is conductivity is like maintained by thermal energy dissipated in OK form. It will be flash for the top and the ground under T. The anti-pad region will be like 180 180. Scroll the flash thermal relief, scroll the file TR180 150. So this should be like giving the top and ground T will be place where we're gonna give the thermal pad. Same as we have did it, same procedure. So J6 and J4 is the part which is connected to the ground, else is open. This is the J2. Give the V positive, V ground. So they will touch the connection which you're gonna connect on that particular hole will connected to only to that layer. Default internals also to be like a flash TCR 180 150. So this is like track piping dimension. We're gonna have dimension for the piping. Like round signal should be have minimum 8 mm, maximum 10 mm. The in between layers. This is like giving the how much dimension of the pipe should be of the signal, which is connecting between the layer. It depends upon three considerations like capacity of manufacturer, the fabrication capability, and the current handling capacity, noise margins. make it the no route thing. This is the routing the fan out for the powers and the grounds. This will make the nets invisible. Open to the constraint manager and select the properties tabs. We want to prevent the power net from being fanned out, so the no route distinction is applied. Go in the route, go in the connect. PCB router route automatically. This will route the entire the connections we are doing with the check the only fan out. We are controlling what type of net get fanned out in what direction of the fan out and how the pins and wires are gonna be the shared. Select the options like out, direction out, specified power net. This gives the location of the shared fan outputs to the V plane, shared output to the V negative plane, the individual fan out to the V planes. These are the for the op amps, for the U1s. These are fan outputs are just the holes coming out from the components which we gonna connect to the output volt. So this is like C1 and C2 get connected to the this is gonna connect to the ground signal. The SMD resistance, capacitance, select top layer, select so this is the components we are going to connect it to top layer. Check the status, DRC check. Update DRC. So Algebra Constant Manager. Select clear for 3 layers. This will running the auto router. We're gonna form the lines of line log to be 90. The width should be like 12 mm. So this will run out once the fan out and manual writing tasks are completed, which we need to make specify the routing path, use the smart route and spectral allegro do files. Select the blue lines are the connections, but as you know there has to be perfect geometry for the routes in order to move in the track for PCB, and also which is also important because of removing the crosstalk impedance, the noise calculation, frequency getting, all this matters. So we have to do perfect routing of that. Just select particular blue line, which is connection which is going randomly, and try to fix it. Properly fixed added element to the net 280. Check it. Unrouted connection remaining U1 U1.3 third pin of the op amp and R1 1. Now go in the PCB router, route automatically, router setup, use the smart router with a minimum grid size of 0.01. Select the grids. All each spacing changes, make it like 25 25. Yep. Make it like this. There should not be no straight turnings or sharp edges in the route. It should be transverses. This has to be taken care. Yeah, that sounds good. No sharp turning or edges. Pin number 2. No sharp edges. Click on that. Straight it out. Move towards output. Outside. Move it. This is the DRC error. So scroll it somewhat more because it's somewhere early. It's not in the minimum range. Scroll it outside. One more grid. Now finalizing the designs. In the part, select the tracks. Go to the export the logic. Export the logic and the capture CIS. So this will export whatever we're doing to the manufacturer directory. This will form .art files. Do the back notation. Now this is the important part, because we're gonna have formed the circuit, but the problem is that we have to give finalized but with the minimum width or matched with the track piping. What we're gonna do over here is we are doing the annotate those things. Now go in the board geometry, form non-etch subclasses, which we want to have no etching. This is like generating the artwork. We gonna make a generate the .drl files which gonna use for the manufacturing people. This include the each shoulder mark, shoulder paste, silk screen layers. So this is gonna be the generating. Now just change the spacing for the non-etching layer. This is like quite redoing stuff. I keep on doing until and unless you don't get any DRC on your layer. Go in the board geometry. So we're gonna form the solder mask top layer where the paste gonna be spelled for the SMD component. This will be the dimension of last pick. So just make a one pick. This will be the area where we're gonna have a shoulder paste top. The region for the shoulder paste will be make a new rectangle. The inside green will be the shoulder paste and the outside one with the shoulder mask. So once you make one patch, you copy and paste at the each and every SMD component. So this one is the one patch we make. Now what we're gonna do is that we're gonna copy that component, copy this, so this will be the particular point where we're gonna have a solder mask, and giving little bit of heat, this make dissolution of solder mask and make the SMD component to stick to the PCB upper layer. This will be like 4 edges of the six pin connector. So because we want to connect the 6 pin connector on the PCB's upper edge, capacitance C1. Make sure it come in the row of the grid, not overlap anyone. Otherwise DRC error will come into the picture. Do not let it to overlap. Go in the manufacturing subclass, active class, and in that go in the plot outline subclass. So we're gonna form the plot outline. Select a rectangular shape. So this will be the outline for the total plot. Whatever files generated in that, this will go to the manufacturer. This file will be viewed by like .art or DRL files, which are useful for the manufacturers. Cover the entire PCB. This is a menu plot area. This is a photo plot. Make sure it is equidistant as the grids so that no DRC comes. You can write the text you want to enter, your name, university name. Go in the artwork. This will generate the Gerber files RS-274X format, which will be used by the manufacturers of PCB. Format to keep it fast file. Select Gerber RS-274X. Go in the package and make solder mask top. Go in the via classes. enter the new film as a we're gonna form silk screens like shoulder marks. I'm sorry. So this will be the all the shoulder top, shoulder bottom information will be in the films. And the ground underscore T. This will make a silk screen. The silk screens are the screens which like we on see on the green plate, where this will be the component name, number, where the component is. This is like a white pattern you see on the green upper edge of the PCB. That's gonna painted by this. So this will be the minimum line, length, clearance, pad geometry. Setting up on the top layer, we're gonna define a layer called silk screen. So this will be like around the component, stating that at that particular location we have to solder the C1, C2, R1, R2, R3, C3. We're gonna make changes over here. This one is now R1, R2, R3 is okay. J1's outline, this one is the J1. Maybe it has a new screen, silk screen bottom. There also will be some regions in the downside of the PCB which you want to paint it as a white boundaries, which clearly shows what particular region it is or where the shoulder is coming from. Going to subclass selection. In the auto cell bottom, go the photo plot outline. Now this will form the V positive, name it as photo plot. So this will like manufacturing a photo plot. V positive, V negative, screen top, screen bottom, top layer, shoulder mask, top bottom. The film should be like 5 mm. Plot mode negative. This one is dynamic shape status, like no edge stays smooth, points on shape. This is like a Gerber file which will report the shapes, edges, dimensions, rotations. And the board geometry go in the boundary. This is a mechanical pin of MFG 125. Select the auto writing. Make sure you do not make any sharp edges, any sharp turn. Make a gradual turns, like slight turns. We are in the top edge. Make it little bit far. In the bottom, positive layer, ground, negative layer, ground T, negative layer, photo plot, positive area, screen top, positive, screen top, positive, shoulder positive, top positive, V negative, B positive, also negative. Select all. This will generate the Gerber files. Create the artwork. Go in the Allegro folder. There will be artwork .art files. These all are the Gerber files. For the top .art V negative, these files you go to the manufacturer and they do all the processing to make the PCB. These .art files are called the Gerber files. Go in the manufacturer section. Now we have to now work on the drilling specifications. What kind of drilling and how much will be the on the top of the PCB. We're gonna print the drilling top to bottom chart. This indicates size, quantity, the type of the drills, like plated, non-plated, and in the PCB what kind of symbols we have used, like star for the non-plated, dot for the plated ones, size for the particular drilling. Go in the NC parameter. Make it as a header. Format is like 2:4. Enhance the Excel formats. This is needed. give the specification as 13.00. This is like manually creating the tool list. The first column will be like the drilling dimension, secondly the either plated, not plated. The third one is the 125. This is dimension, non-plated one, layer 4. This is like we are manually doing the stating the dimension of the hole, type of the hole, and the numbers where the locations is. Save this NC tool file. This will be needed with the Gerber file to be given to the manufacturer so that he can estimate the specification of the hole diameter and the type of the holes we're gonna make it. NC root bit, NC root bit will be the, unlike the NC drill process, you have to specify the routing tool list. You have to specify the NC route tool list, making the drill tool. It contains the light that include the bit diameters and tool number for each cutting. These are the cut marks. We have to specify offset. This specify the bit used to cut around the board is 100 milli in diameter, so the cut marks and the placement of the route line will be based on that cut marks and the broad outline. The line length is not critical. If the board is not simple rectangle, then you could select both inside and outside corner. The next step is to place an outline along the cut path. Start from the outside edge. The corner one is the cut mark, and the cut path is the path between the two portions. So scroll, this should come in the middle. The middle of the cut path should come in between the outer section of the inside layer. Scroll down the cut path. So this cut path will go from the center line of the cut marks. The line is cut path and the point is start point. And this is the board outline which we are drawing is the board outline which go from the middle of the cut path. So outline should become in the middle of the center line of the cut path. Make sure that it passes to the middle grid of the cut path. Scroll it down, make sure it's in the middle. So this will be the cutting edge for the board. Usually it is recommended to make the PCB more rectangular. If more transverse shape is that it's probably get more difficult for us. Start from the center. This is horizontal line segment on the board geometry and C root path. Make sure it's okay. Number it as a 1. Simply place the 2, 3, 4, 5 at the each corner end of the figure. You can place stay starting and direction indicator. Number 2. Now we have to finally make the NC route. The NC route we can find in the dialog box. Just enter the name of file, route feed. You can change the NC parameter if necessary. The NC for route file will be the broad name.ro. It will be the broad name.ro. Now this is for the 4 layer. If you don't want to make a 6 layer, you can go for a 4 layer. Top layer, load the file. The bottom dot art. This one have DRC errors. This is coming to the route problem. See the layers. This is 4 layer. Because increased the cost of 6 layer was like $500, so I made PCB try to make of a 4 layer. I decreased the layer by not giving the V positive, V negative at the 2 layers. I made it on 1 layer. See in the 3D view, the op-amp, 2 resistor, 2 capacitor, 3 resistors, 2 capacitor, 2 SMD capacitor, the 6-pin connector at the end, downside, the partition of 2 layers with 4 holes. This is from the down view of the PCB. Rotate. These are all the thermal relief pads we can seeing right now. Thermal for all the SMDs. View the power layer. This is all the power layer. So J1 connected to V plus. This is V plus connected to C1. This is V negative layer on same plane connected to C2 pin number 1. This is the via. 2 vias we have connected in the V plus layer. This one is V minus. This is via for the V minus. In between is the U1 capacitor, U1 op-amp. This is via for V negative. So this will like bypass. If you place a component, it will bypass and directly connect it to the ground. So these are the SMDs, or we have go through component. They will touch directly the ground. Go to the see the layer for the ground layer. Click on that, you will see the ground. Ground is connected to the capacitance C2's second number pin. C3 is via ground signal. C3 via ground signal. This is another pin of SMD capacitance is connected to the ground. Thermal relief pad also one connected to the ground. Pin number of 4 of connector is ground. Pin number 6 to ground. Ground connected to one end of the resistor SMDs. This resistance R3 is the feedback resistance. So it was connected between op amps output pin and input pin. So R1 and R2 is connected to one end ground because they are at the input and output. This is the size of the drilling, plated holes and non-plated holes, size and their quantities. Put of the grill. This is the plated, quantity is 9. small ones are 51. All this is a diameter which is needed to in top. This is mechanical one for the screw. It is MFT 125 and MTG 125 drill hole. Mechanical pins. These are the cut throughs. J1 ground signal. Go with the CAM document. This is Design Explorer in which we can see all the video, all the files, artworks. This will show you the layer wise the files which will goes to this Gerber files which are going to the manufacturer and how they're gonna see it. Your top layer, your bottom layer, your solder mask at the top, solder mask at the bottoms, the silk route. This will be the region around the component, like white line. This will be the power dot, half is V positive, half is V negative. Photo plot area, the green screen, the ground art. This is all the ground around the bottom layer. This is the art underscore parameter. All the drilling holes, MFT 125 at the end of the PCB. Small drilling holes for the axial component capacitance. Border outline where the cutting will take place. This is the bottom. This is the outer edge of the PCB, which is and inner where the cutting will take place. Outer. This is the power, half negative, half positive. Silk screen indicating the components. Shoulder mask. Top layer of copper tracks each.